In this video, we're going to go over Simpson's paradox in the form of a red pill, blue pill scenario. So, let's say we have the following data on how well these pills work for each given gender. And we want to know which pill would we give to a random person. Looking at the data, it may seem fairly obvious. Well, let's dive into it a little bit. We'll say person is male. Well, what pill would you want to give them? The males are on the top area here. We have a 83% chance of a positive response with a red pill and a 78% chance of a positive response with the blue pill. So we'll say give red because we want a positive response. Well, what if we have a female patient instead? So say person is female. Well, then what pill are we going to give her? Well, if we look down here, we can clearly see that with the females, there's a 50% chance of a positive response with a red pill, and only a 40% chance of a positive response with a blue pill. So we would also give her the red pill. So say give red. Now here's where the paradox comes in. Say unknown gender. You would think that if males respond better to red and females respond better to red, then it's obvious that we should give this unknown person a red pill too. But what happens when we add these up? So, giving a red pill, let's do this in red. Red pill, well, we have 83% responding positive for the males, 23 for the females. Add those together. That's 106 out of, 100 plus 46 out of 146 respond positively. Then what happens if we look at the blue pill? Blue pill. We've given it to 105 people total, and 78 plus 2, 80 out of 105 respond positively. So 80 out of 105 respond positively. Well, that may not be too surprising, but look at these fractions. If you divide out 106 by 146, that comes to about 72.6% chance of a positive response. So 72.6% positive response. And what happens if we look at the blue pill? 80 divided by 105, that's a 76.2% chance of a positive response. And that's where the paradox lies. If you know the gender is male, red works better. If you know the gender is female, red works better. But whenever we combine them, the blue pill has the better numbers overall. And the key to this paradox lies right here, in this section of it. Anytime that one section of the data has a significant number of fewer people, that can skew the data. So the moral of the story is try to take even samples instead of random samples. I know I'll catch some flack for that, but that's how I would prefer most things be done. And Simpson's paradox, as long as all samples have even numbers taken, will not arise.